Covalent molecules are molecules that are held together by covalent bonds, which are the electrostatic attraction between atoms when those atoms are sharing electrons. So unlike ionic bonding, where the electrons are transferred between the atoms to make ions, which are then held together electrostatically, the covalent bonding involves sharing electrons between those atoms. So we'll consider the simplest example, the H2 molecule. So we can write H2, or we can write an H bonded to another H using a line. Or we can write it in the form of a Lewis diagram. And in this Lewis diagram, we have hydrogens on the outside and the hydrogen valence electrons in the middle. These two electrons in the middle make up a single bond. And we could also write this using protons and electrons. So this diagram with protons and electrons is representative of a bond between hydrogen atoms. The electrons are shared in the middle between the two nuclei. And the positive charge for hydrogen 1, or hydrogen A, is going to be attracted to the electrons in the middle. That means that the hydrogen is going to be pulled towards the center. The same thing happens to hydrogen B. The effect is that the hydrogen atoms are pulled towards the shared electrons in the middle. Of course, there aren't just attractions, there are also repulsions between like charges. There are repulsions between the two electrons, and there are repulsions between the protons. And if you want to do some horrifyingly simple math, there are 4 attractions and only 2 repulsions. So the net effect is that there is an attraction. And of course, we can look at a more complicated example. We'll look at chlorine, diatomic chlorine, the Cl2 molecule. So the Lewis structure for the Cl2 molecule has 14 electrons, and 2 are shared between the chlorine atoms. And you can see that each chlorine atom has 8 electrons, so it has a full octet. And there are 2 electrons that exist in a shared position between them. And when they have these 8 electrons together, it's referred to as a complete octet, and most covalently bonded atoms are going to have that full octet. So when we show these covalent bonds by joining effectively 2 atomic Lewis structures, we're showing what are known as molecular Lewis structures. And molecular Lewis structures, just like atomic Lewis structures, have different components. So this would be an example of an atomic Lewis structure for chlorine, and it has several lone pairs of electrons. And when we draw the second chlorine atom, we've reproduced our molecular Lewis structure. And just like atoms, molecules can have lone pairs of electrons. And these lone pairs of electrons are also often called non-bonding pairs. The chlorine molecule, the Cl2 molecule, has 6 lone pairs. And the electron pairs that are between the atoms, that are shared between the atoms, are referred to as bonding pairs. And of course, we can show more complicated covalent structures that are also possible. So consider something like formaldehyde, which has the structure CH2O. So formaldehyde has a more interesting structure than other molecules we've seen in this video. It has a double bond, and we can represent this using Lewis structures as well. Carbon has 4 electrons. Each hydrogen contributes 1 electron. So now we can see hydrogen and carbon being connected by bonding pairs. And there are also going to be electrons contributed by oxygen. So the oxygen-carbon bond has 2 bonding pairs. And when you have 2 bonding pairs, you have 4 electrons. That corresponds to a double bond. And we could get even more complicated and show triple bonds, where you would have 6 electrons being shared, again, in between the nuclei and holding the nuclei together.